We shall now take a look at how do we write algorithms and why or what are the reasons we use algorithms to develop the logic of a program. That's number one. Number two, what is the difference between writing an algorithm and what is the difference between writing a program? And we'll wind up this session with a discussion on the commonly used symbols or terminology used for writing algorithms. Let's try to answer the first question. How do we write algorithms? Algorithms are written in an English-like language. It could be Hindi, Kannada, any of those languages, and with a flavor of one or more programming languages before writing the program. So algorithm is written in English-like language along with a certain feel of a programming language which you are going to use to code the particular program. This thing will be clear when we take a look at our first algorithm, which is say addition of two numbers in the next 2 or 3 sessions. Until then, just hold on. Why do we write algorithms? The advantage of algorithms are many. The first is you can write an algorithm in an English-like language, even if you do not know programming. That particular logic can be converted into a program in C, C++, Java, Fortran, COBOL, Pascal, Python, any language. So algorithm writing is not dependent on the language of your study or which you are comfortable with. So even a non-programmer can write an algorithm to solve a given problem. As you will see, as we proceed in learning programming, an algorithm can be very easily converted into a program. Number three, the advantage of an algorithm is since it's a ordered finite sequence of solving a problem in a step-by-step manner, if there is any problem or any mistake in the output, we can immediately go from step by step and find where the error is. Say for example, I am trying to find the area of a triangle using the formula half base into height. Let us say I only read the base and I forget to read the height. So when I am trying to calculate area is half base into height, I'll automatically know that there is some problem at the prior step because height is not read. So it assists in the step-by-step tracing and thereby easy correction of errors. The advantage of algorithms is it's more English-like and uses a few mathematical symbols which we shall take a look at shortly. Now, what are the differences between an algorithm and a program? Both are actually instructions or directions on how to solve a problem. But the difference between an algorithm and a program is algorithm is written in simple, plain English-like language which is understandable to most common people who are working on that problem. Whereas a program is usually the conversion of an algorithm into a series of steps or instructions following the syntax of that particular high level language which is understandable to that particular compiler or computer. Algorithms should be understandable to people. Programs should be understandable to the compiler or the computer you are going to run the code on. So algorithms is for people, programs are for the computers. I hope this clarifies your fundamental questions about algorithms and so on. Now what we shall do is we shall try to take a look at the different terminology used in writing algorithms. Just as maths has different symbols and terminology, algorithm too has different symbols and terminology. So in this session what we'll do is we'll try to take a look at different terminology associated with algorithms. So let's go through one at a time. The first thing you need to understand whenever you are solving a problem by a computer is any data item you need to read or use for calculations should first come and reside in a memory location. Now, for side of a triangle, base into height, you may enter one value for base, I may enter one value for base. So, values which can change are known as variables. But suppose I am calculating area of a circle. I am saying area of a circle is pi into radius. Now pi is not going to be entered by the user because pi is a constant. So that is a constant memory location whose value is 3.142, which does not change. So let's try to understand a little bit about solving a problem. The first thing is any data you read is stored into memory locations. For example, the value 10 is stored in memory location 2000. The value 20 is stored in memory with the address 2004. 30 is stored with the address 2012. All these addresses you can think of the addresses of your houses. Every house has an address, so memory location also has a address. But addresses keep changing every time you run the program. So in order to make it simple for us, instead of referring to a memory location by address, we refer to them by names. For example, memory location 2000 is A, 2004 is B, 2012 is sum. So every time this location may change, but still I'll refer to 10 with always A, 20 with always as B, and sum as always with 30. So the moral of the story is memory locations which change are known as variables. Example of them are A, B and sum. Because you may enter the value of A as 30, 40 and you will get 70. I may enter 10 and 20, I may get 30 here. So both A, B and sum are changing. So these are known as variables. Memory locations or variables have three things associated with them. The first is they will have some value. In this case, the value is 10, 20 and 30. They will have some address. What are the address? 2000, 2004, 2012, which are the addresses of A, B and sum respectively. So this should be your first concept. Now, in order to solve a problem like finding area of a triangle, area of a circle, largest of three numbers, leap year, okay, all these things will be using certain arithmetic operators. These are common symbols we use in maths also, so nothing really changes. For example, this is addition, subtraction, star stands for multiplication, forward slash stands for division. That means it gives you the quotient of the division. So if I say 20 divided by 10, so if I say like this, okay, let me use a different color pen, it doesn't confuse you. So let's say if I say 20 divided by 10, so the quotient is going to be 2. All right, so this gives you that 2. Mod gives you the remainder. So if I divide 20 by 10, what is the remainder? Remainder is 0. So mod, using this word mod or percentage, stands for the remainder. Division gives you the quotient 2, mod gives you the remainder 0. Now relationship operators. Suppose I want to compare A with B. Okay, so I can do something like this. Okay, I can say, is A greater than B? Is A lesser than B? Is A equal to B? Is A greater than equal to B? Is A less than or equal to B? Is A not equal to B? So here I am using this relation operators like this to compare the value of A with B. What is the result of comparison? The result of comparison is going to tell me true or false. In this case, A is 10, B is 20. So the result of this is false because 10 is not greater than 20. So a comparison will only give you an output true or false. Now let me come to input and output. Suppose I have to find the sum of two numbers A and B. In order to calculate the sum, I need the values of A and B. You can accept or ask the user to enter the input by using the following words. The following words are input, read A comma B, get A comma B, scan A comma B, all mean the same. So if I want to enter values, I can say input, read, get and scan. If I want to display the sum, I want to display the sum after calculation on the screen, then I'll say output, write, show, display, print. These all mean the same. Now let us understand a very important difference between what is a constant and a variable. If you see here, the value of A, B and sum can keep changing every time based on what the user enters. Whereas if I'm calculating the area of a circle, okay, I'm going to use a memory location called as pi. I have drawn it with two rectangular boxes indicating that this value at memory location 2008 is a non-changeable, and data item which is non-changeable is known as a constant. An item which changes like A, B, sum is known as a variable. So if I'm calculating the area as pi into radius, this is a variable, this is a variable. pi is a constant. Now I have already told you the concept of what is a variable, what is a constant, and what is a address. So A, B, sum are all variables. 2000, 2004, 2008, 2012 are all addresses. Now you need to understand something really fundamentally important, which is assignment versus equality. Suppose A is 10, B is 20. If I do A is assigned the value of B, that means the value on the right hand side is copied to memory location on the left hand side. Since B was 20, A also becomes 20, B remains as it is 20. So in assignment, the value on the right hand side is copied to the memory location on the left hand side. So here both A and B's value does not change, but A's value gets changed to 20. But suppose I come up with the question, is A equal to B? I'm asking the question, is A equal to B? A was 10, B was 20. This is false. When I'm comparing, the value of A and B do not change. Just the comparison happens. This is assignment. This is comparison. If I'm using is with this fellow, I'm comparing the values. If I'm using this fellow, this is an assignment. Lastly, every time I'm not going to write the statement, write an algorithm. WAA stands for write an algorithm. So in the next session, we will take a look at something really interesting, which is trying to find solutions to a few puzzles, because I want to wake up your mind to get you started thinking. Because the biggest problem I notice why people are not able to understand programming is the habit of learning things by rote or memorizing. And this, especially in our education system, unfortunately, that is required to score good marks. But that actually hurts you big time when you're learning computers, and it is that skill to memorize is of no use when you go ahead and work in the job. So learn to develop understanding and ability to solve problem. Take a look at the next video where I give you a few puzzles. Try to rack your brain to find the solutions.